In this video, we're going to discuss how to simplify radicals with variables in the radicand. Let's start with a few review problems. First, in all of these first three examples, we have an index that divides evenly into the exponent on the variable in the radicand. So in the first problem, we have an index of 2. That means it's a square root. We want the square root of 25x to the 6th. Square root of 25, recall, is 5, and the square root of x to the 6th, if you divide the index into the exponent, you get x cubed. In the second example, again, we have a square root, so the square root of 81 is 9, and then for the variables, square root of a squared is just a to the first, and the square root of b to the 10th is b to the 5th. Again, I'm dividing the index into these exponents that are underneath the radical. And for the last one, cube root of 8m to the 12th p cubed, cube root of 8 is 2, cube root of m to the 12th is m to the 4th, and the cube root of p cubed is p to the 1st. Now you might notice that I did not include any absolute values in my answer here, and that's because I've already told that the variables are not negative, so I don't need to put absolute values to guarantee that. Now let's look at some examples where the index doesn't divide into the exponent evenly. So this is a square root of x to the 5th, and you'll notice that the invisible index of 2 here doesn't divide into 5 evenly. So what I'm going to do is break apart that x to the 5th as a product where one of the factors involves an exponent that 2 divides into, like x to the 4th, and then the other factor doesn't. So x to the 5th can be rewritten as x to the 4th times x. And I'm going to rewrite that radicand using those two factors. And then the one factor where the index divides in evenly, that's going to come outside of the radical in its simplified form. So the square root of x to the 4th is x squared. That's the part that comes out. And then this piece over here, that's going to stay underneath. So that's going to be x squared root x. For this one down here, cube root of m to the 8th. So I want an exponent that 3 will divide into. So, well, I can start with m to the 8th is m to the 7th times m. But that doesn't really help me because 3 doesn't divide into an exponent of 7. So instead of peeling off one factor of m, I'm going to peel off 2. So I'm going to rewrite it as m to the 6th times m squared. And that will help me because 3 divides into that exponent of 6 right there. So I'm going to rewrite this as the cube root of m to the 6th times m squared. And then again, this one, that the index will divide into the exponent, that's going to come outside of the radical in its simplified form. So the cube root of m to the 6th is m squared. That's outside of the radical. And then I still have a cube root left with this factor underneath it. And notice that in both of these answers, the exponent that's left underneath the radical is smaller than the index. Couple more with more complicated radicands. Square root of 18x cubed y to the 4th. First of all, with the square root of 18, I'm going to rewrite that as a product that involves a perfect square. So the square root of 18 is going to be, let's see, 18 is 9 times 2, and I like 9 because 9 is a perfect square. Now I'm going to come over here and look at that x cubed, and I'm going to rewrite that because the index of 2 here doesn't divide into the 3. So I'm going to rewrite that as an x squared times an x. And I like this one because that's a perfect square. Something can come out. And then the y to the 4th, well, the index of 2 divides into that 4, so I'm going to leave that one alone and just rewrite it y to the 4th. So all of these perfect squares, these are going to come out of the radical in their simplified forms. So the square root of 9 is 3, the square root of x squared is x, and the square root of y to the fourth is y squared. So those are going to be outside of the radical. And then what's left underneath the radical is the other stuff, the 2x. Okay, fifth root of 32 m to the sixth and 12th. Let's see. It turns out that 32 is a fifth power of 2. So I'm going to rewrite that. In other words, 32 is 2 to the fifth power. Now the m to the sixth, let's see, I need to rewrite that so that 5 will divide in one of the exponents. So this is going to be m to the fifth times m to the first. And then n to the 12th, well, I could rewrite that as n to the 11th times n, but that doesn't help me. Helps me more if I rewrite it as n to the 10th times n squared, because 5 will divide into the 10. So this one is going to come out of the radical in its simplified form, which is 2. The fifth root of m to the fifth, that's going to come out of the radical in its simplified form, which is m. And the fifth root of n to the 10th is going to come out of the radical as n squared. 2mn squared outside of the radical, and then I still have a fifth root of mn squared left. The last topic here is how to simplify a radical when it's given to you with a rational or a fractional exponent. So recall that x to the 16 over 7, the denominator is the index, and the numerator is under the radical. So this is the seventh root of x to the 16th. Using the techniques I just described, I'm going to rewrite that x to the 16th as x to the 14th times x squared. And again, that's because the 7 divides into the 14. Then I'm going to pull this out of the radical in its simplified form. So the seventh root of x to the 14th is x squared. So this simplifies to be x squared times the seventh root of x squared. And you might notice that if you just simplify or rewrite the fraction 16/7 as a mixed number, you get 2 and 2/7. This whole number right here is the exponent that shows up outside of the radical. And then the fractional part that you have left, the 2/7, that's the exponent in this radical form with the 7 as the denominator, and this 2 that's underneath the radical is the numerator.